Today we're going to talk about the OVN traffic flow and troubleshooting. So I'm trying to prepare really beginner session, but there will be quite a lot of examples of these outputs initialized, and around the slides will be QR codes. So if you want to go deeper in the details, please keep your phones ready just to scan it, or just wait until after 1 or 2 months they will send the slides to everyone and this video.
Guys, please close the door, we don't hear.
Yeah, so who am I? I'm right now cloud architect. As you see, I'm supposed to be the master at PowerPoint, but previously I was a developer for the OpenStack community and a network engineer, so I have experience with all of this stuff also. I worked in cloudification. We provide most of the cases private clouds for end clients with some specific architecture as customer requires, and we use really specific and unique installation for the OpenStack. We use Kubernetes, then Argo CD with GitOps, and then on top of it we use OpenStack. So if you're quite interested in these installations too, you can check our video recording from the previous session in the France also, in the previous year, where we covered all these details. So the small agenda we're going to talk about today, I will give you a quick review for the OVN architecture. We'll get you information about mapping resources. I hope most of you already know this. The interesting part, the troubleshooting that we actually faced in our installations. But I think after that we can have small question and answer session. So let's start with architecture and mapping. You probably know that the OVN ML2 plugin for the Neutron is a next generation network system for the OpenStack. And the biggest difference that under hood it uses not RabbitMQ, which is caused a lot of problem previously with original Neutron, but it uses OVSDB protocol plus events between all these diamonds. It uses all L3 agents implementations inside, which is done by internal system in OVN. I will cover it a bit later. It uses a unique HA system based on the BFD inside the architecture. So these routers, layer 3 routers, spread across several nodes in OVN. DHCP also OVN, they use own solution for this. Metadata still is kindly part of Neutron, so it's additional agent which is running at the same nodes with compute, and it's proxy. BGP and L2 gateways really rare use usually on the installation, but they also exist on OVN, provided by OVN guys. So yeah, let's jump to the architecture. If you see the QR code there with some description from official documentation how it works. I've tried to prepare this diagram as simple as possible already, but it's quite impossible. But the main thing that there are two big parts of OVN: the north bridge and south bridge. The south bridge is kind of data path in OVN world. So this is something that actually configures the compute nodes, that configures the open floors, etc. on the nodes. But the north bridge, it's a counterplane, let's say some layer which is working with the Neutron directly and translate this information from the objects of Neutron to the objects of OVN, and tells how exactly the south bridge should work and apply this configuration to the nodes. The interesting part that There are also can be configuration when the gateway or slash network nodes can be separate in this architecture, but exactly the same daemon usually works for both of the cases. So it's contained the routing for both of the sites, and there are two different gateway modes for this OVN controller daemon. And depends on these settings and how it runs, it can work for the north and south traffic or east-west traffic in your cluster. Or it can be deployed to one node exactly and works like hyperconverged-ish node. So everything will be together, gateway node on the compute node. Yeah, so all of these configurations and description you can find by this official link. But under hood, there are still OVS DB server on each node. There are still open the switch with open flow like it was before with traditional ML2 plugin OVS for the Neutron. So when you try to debug any problems in OVN, you need to understand what's going on under hood after you run some CLI command. You have to understand what's going on inside. So I want to start with mapping. Here also QR code, and in this QR code you can find the gist in the GitHub, where all of these outputs in a full measure. There are all information interesting. I marked the common settings, which you can see here in actual Neutron and in data inside the logical switch in OVN. You will see the same data, and on this particular slide, I can give you some insight that when you debug, try to every time check this external IDs for every resource in OVN, because there should be copy-paste data from the Neutron database, actually, and by checking some fields, you can understand is it actually was applied to OVN or not. Is it actually already in a correct state, or it's outdated? An example here, how the settings VLAN transfer is converted to other settings on the OVN level. And in most of the cases when you try to debug OVN, you use this CLI2, OVN, and BCTL with find or list command after and name of table. And in most of the cases, these objects from a Neutron easily can be mapped to some additional object, new object in OVN one-to-one. So it means you should not go further really deep to debug it. Yeah, the next this is the next example is OVN DNS, how it's configured inside the OVN when you create the private network. This is example for the private network. As you can see, OVN from the start creating the PTR records inside the database. And it's also create the records for the machines itself. So there are in this network running only one VM, test VM1, which is obvious. And this data will be used for internal resolving. So it means if you run the second virtual machine in the same private network and you try to resolve this test VM1, this request will go to the OVN, not outside the cluster. Inside OVN, you will resolve this domain. And this is provided also by OVN. So if you have some problem with internal resolving, you probably should check these records inside this table, DNS. Yeah, let's go to the next. This is how the port of the networks is actually mapping the resources. And this part can be quite complicated because there are several types of ports in OVN. They try to reuse the same table for the same kind of logical objects. Here you can see the example for the usual ports, which is just for the router, the gateway port, which is created in this particular network. But these ports we will cover a bit later. Yeah, and this is example for the compute ports for the virtual machine. So the same network, you will see the same logical objects. In this case, it's logical switch port. And this field is really important type. There are actually many types of interfaces. If you check the official manual for the OVN architecture, you will see that there are around 10 of different types, but in most of the cases we're interested in this one, in this port. Usually you will see the empty field, which is means this is a visual compute port for the virtual machine or container, or something like that. The router ports are connected to the virtual routers. The local nets ports is used when you use provider network, so they end up in PRX, in your OVS, in the end. And the local ports, it's a special type of ports. It's a dummy interfaces, let's say, which is created everywhere on all of your nodes in the cluster. And they're used by OVN to be able to route traffic to some specific services. In this case, in most of the time it's used for the metadata service, which is running on each compute node also in front of OVN controller. And the local ports are actually using to forward this traffic to the metadata. So, and yeah, you can see on the slide how these resources are mapped. Also, you can see that most of the data from Neutron and Nova actually mirrored to the OVN. For example, by OVN, you also can see where this port deployed, where it belongs to, MAC address and IP address, and etc. And the next important part for the private network is DHCP and how that works inside the OVN. So here the example where I created the simple configuration with VM connected to the private network and to the router. And inside I also configured host routes and the static routes, which is different. And the host routes here in this case will be mapped to the DHCP options. This is the special table inside OVN, which contains all these DHCP settings. And if you configure some special DHCP options, which is also supported by OVN, you will see here the list of all of these options for the booting, for the specific reasons. So in here you can see the router, and actually these host routes which I just configured in a really weird format, which you should keep in mind. They just separate with column, and that's it. It's not really useful when you see it in the screen. You can see in the GIST, which was by QR code, that there are kind of mess when you try to do it in the real life. But yeah, this is what we have. And also interesting part that all of these DHCP answers for the requests in this private network will be from router. So it means if you run DHCP request from any virtual machine inside the private network, you will see the answer like from the router. But it's not from the router actually. All of these requests handled by the local OVN controller on the specific compute node, and it's forwarded by OpenFlow in OVS. So you have to keep in mind that this actual answer is not from a virtual router that you created logically. This is from tricky DHCP server connected directly on this host. And you can see it by MAC address, also configured here in these options. So you can understand it by these fields. Here things become a bit more complicated because virtual routing they again try to reuse the same structure. For example, for the virtual router, when you try to check it, and here you can see that I use the shorter version of this command, OVN and detail show, not a list, because it's rather on top of the usual request to the tables of OVN, just to give you a good readable output to be more useful. And here you have example that two interfaces connected to the router, which one of them will be public interface, face to the provider network, and another one to the local. They both presented in the same table and connected to the same object, which is test router. And also you can see that even in OVN you will see the same naming. So we save names for the objects too, which is really helpful. But the interface is kind of the same. And the difference only that the ports for the actual public network, for the provider network, have gateway chassis usually inside this output. But internal interfaces have the same IP addresses and the same MAC addresses configured. In the next slide, you will see this interface. This is the same output, but with a full command list from this table. So it's the same data was on the previous slide below, the red one. This is the detailed output already. So this is an internal interface, how it looks like. Usually, I just cut all this useless data below. But this is a logical port for router which is faced to the public network. And here things a bit complicated. As I said, they usually use mapping one-on-one, so you can take one resource inside the Neutron and then map it directly to the OVN by one command and see kind of exactly the same data, but this is not the case. Because this, for the virtual routers, they use this native HA system. When you run one virtual router inside your cloud, you actually run at least 5 copies, by default 5 copies of this virtual router. Copies, I mean there's some logical objects on your nodes, but it's not namespaces as it was before in the previous Neutron ML2 plugin. And how you will see it, usually when you try to check the logical router, which is the first one command, you will see this gateway chassis, as I said. And there will be the list of these chassis. This chassis actually presents the physical hypervisors for the nodes, gateway node, where these ports belong. And by next command, this list gateway chassis, you will see where exactly they deploy. And then the third command, the most important thing that here you already go not to the north database, but south database. So this is already a different database. And here you can see that host name where this port actually deployed. Then you can find how that works. And only one option actually in this table tells OVN that this port should be used for the logical router and should be used for the routing east, north, south in your cluster. This is the option enabled chassis as GV. Right now they invented another one option, which you will find in the documentation for more gradual configuration. But this is pretty much everything that you know to debug the ports and how to understand where your traffic actually is going when someone tries to reach your public facing IP address, for example, the floating IP. Yeah? As I said, they have HA system inside the OVN, so it means there are lots of objects and any of them can get the traffic, but in one time there are only one actual logical router which is getting this traffic. And you can see by this command, LRP get gateway chassis, which is showing you priority tables for the traffic. So here the list of all of these gateway chassis for this exact port, and you can see different priorities, which is I marked with red. And the highest priority, it means the actual active interface right now, which is getting all of this traffic. So it means right now, in my case, in this example, it's master 1 node, which is getting all of this traffic. And if it's gone, yeah, the priority will be changed, of course, and the traffic will to another. Yeah, how you can understand from the database itself that this exact port is a part of HA configuration and in the router by this option, recite on redirect chassis. If it's true and if it exists, it means that this port is actually spreaded, high available, and etc. So here, again, 2 commands which you can use. Unfortunately, guys, from this side, signal. If you want, I can show you a slide personally. So the next part is OVN agents. As I said on the second slide with a huge diagram, that we have 2 types of gateways, 2 types of OVN controllers, so they can be run in 2 different approaches. And here you can see the example. So the OVN controller runs in both of these nodes, but one of them is called OVN controller agent, and another one gateway agent. And the difference is that gateway agent can serve, can work with HR routers, so it's actually absorbs all of this traffic to the virtual routers. But another one, controller agent, it's working just like configurator for the OVS for this specific node. It works with metadata, etc. It's getting requests from the North database, etc. But yeah, it doesn't work with chassis gateway. And you can see here, yeah, the example of how they different. So actually on this slide I show you the official documentation, how different these floating IPs when you use the DDR configuration or not on your installation, and really good explanation like this link. So you can use quote. A SNAT configuration, which is actually mapped one-on-one from Neutron to the OVN. So it's difference between SNAT and DNAT, which is floating IP. Actually, it's just in these 2 fields, as you see on the example, and all of them ended in the table NAT inside the OVN. I want to speed up to some interesting part. Just skip some examples. Yeah, you know, this is I've described in my topic that I will not give you serial bullet. Actually, it is. So you can see. Usually you should just shut down everything, start it again, and it will work. We do it most of the time. No. Actually, no. I will fastly go through the problem that we faced, unfortunately. So one of the problems that we faced, usually, if you shut down one of the compute hosts without any preparation, like power cut, when it starts again, you will probably see duplicated metadata in control agent inside the tables. And the problem is that you cannot just remove this by command Neutron agent delete, because it's impossible with OVN agents. They disallow this command. Maybe they reverted it back in the last releases, but in our 2024 it was impossible to do. So we have to do the trick, find the chassis, remove the private chassis, remove the agent from cache. Here's some tricks how to do it. And if it's not, for the previous slide, yeah, shut down everything. Another problem that we faced, if you have two private networks connected to the same router, and router is supposed to route between these two private networks, different subnets, but these two private networks have different MTU, it will not work on the OVN. Because OVN is not providing actually the good packet fragmentation. It was fixed already in the last release by this link in the Red Hat guys. They fixed it because they also faced this problem, of course. But if you want to use this fix, you have to use this 24 version, which is available in 2024.2 release of OpenStack as far as I remember. Yeah, and the last one, the difference between distributed floating IPs and how to go from DVR to non-DVR or back and forth. We just use this table, not where this IP address is presented, and the difference is between DVR floating IP and non-DVR. This is one field, external map. If you set it, it will be DVR. If you remove it, it will be opposite. Because this setting actually works everywhere. It's one for the config, but during the process when you decided to move to the DVR, you have to fix sometimes manually. But again, if you don't want to, shut down Neutron services, not if you can. Yeah, here I give you example how it actually can be set up on the table. Yeah, and the last, I think probably most of you already faced this. This is when you have different OVN bridge mappings in your configuration. This is a really actually most common problem on the previous plugin too, when you forgot to update one electron config on one specific node, and there are a bridge not existed, and you face it only when you try to run VM on this specific node. The same for the OVN. This configuration should be spread across all of the chassis, so it means so you have to fix it. I think we'll have to finish because the next speaker already here. No? Next speaker? No? No? Outside? Okay. The last thing about debugging in this simple configuration, as you see, virtual machine, router, and the network connected to the public network. How to debug it? In most of the cases, you can use the trace tool. I know that it's quite complicated, and usually no one wants to translate this, but it's kind of the same as TCP down. If you use it sometimes, yeah, you probably will create this source. This is an example of how the unicast traffic for specific TCP port will go from the private network, from a specific virtual machine, and end up in a public network. And here you can see that in the end, it will be translated by NAT table to the public address and go to the public interface. Actually. So it's quite useful, and I recommend to use it, but yeah, it takes some time. Yeah, and the last but not least, the script which you use for migration from the old Neutron ML2 plugin, OVS, to OVN. They recommend to use this script, which is converts the actual data in the Neutron database and applies it to OVN for the migration part. But actually, it also has two really useful keys, logs and repair. By logs, you can check if you have some desynchronization inside the databases, but repair actually try to restore the data and fix it. So this script is really useful and it's still updated. It's not old. And the last, the links. All the information that I just told you in these links, or some additional information in these links. I will keep this slide here. I hope Thank you.